Hi everyone and welcome to Elvatech YouTube channel. My name is Sergey and here with me our expert Dennis, and today we are going to dive into interesting topic comparing XRF with the other analytical methods.
Hi Sergey, hi everyone, it's happy to be here, and as we just discussed, it seems like we kind of starting our own podcast, so yeah, moving to this forward.
Yeah.
Yes, sir.
So the first question, Dennis, let's start with the basics. What is XRF and how does it work?
All right, so basically it's X-ray fluorescence and it's the method that works. Let's visually imagine that like every material has atoms and molecules, right? Molecules. So let's imagine atoms, and it consists of electrons, protons, as we know, and neutrons. But basically, we are interested in electrons. They are mostly speaking to our method. So when X-ray emits to the sample, to the material, we actually tackle the inner electrons of the that actually locates an inner shield, and we spread them, and then it replaces it with the electrons from outer shield. But those from inner shield we collect in because we have our detector, which actually collects its energy, and each element has its own energy level, and that's why we understand which element is connected in this exact material and in which concentration, because due to the energy then we face in a spectra, we can analyze and understand what material actually what it consists of.
Okay, it's like an analytical magic, and I know that it works without damaging the sample.
Yes, absolutely. It's totally non-destructive method, and as you said, it looks kind of magic, because before I came here, I know just the basics, But firstly, when we head up to practice, and I saw that you take a device, you point it, you measure for 5 seconds, and then you have the full picture, I was like, come on. It has to come from somewhere. You can do it that's fast. But then we got deeper into this method, and now you understand that the magic is the most practical way to to analyze anything. So with the magics of XRF.
Yeah. And what about the speed of the results?
Well, as we know, we are the fastest method, because the speed is, you can settle it from like 1 second till 1 minute. It depends on this material or at the data that you want to receive and how accurate it is. But basically, XRF fluorescence is one of the fastest methods to get the full picture of elemental composition in the material. Yes.
Okay, so let's talk about the other methods. That we know that XRF isn't the only one method.
Absolutely.
Can you tell us about some alternatives?
Yes, sure. Well, we have also optical emission spectrometry, which is also a well-known and popular method. And also we can consist the mass spectrometry here. So it's kind of two methods that, also well known for this kind of analysis.
And I assume that these methods have their downsides comparing to XRF.
Yes, sure. We can say that every method has its own benefits and downsides. And this method's basically, optic emission method is really good for analyzing organic content. Basically, some things that our method can go deeper and analyze such kind of elements like carbon or oxygen, basically because they are too light for us. Their energies are too light to be spotted. Here we have the optical emission method that can analyze carbon and can analyze oxygen, and is actually really effective on the light matrix. Absolutely. But what about downsides with it? This method requires sample preparation. Usually it can take time. It depends on the skill of the professionals who do it, or it depends on the material. But, to prepare for just one analysis, it could take hours. So basically, you need to prepare the sample. Then this sample during the analysis will be destructed of somehow, because it has to be influenced, like the material has to be influenced to get such a light matrix from it. So the material would be damaged. And for sure, the analysis takes time also. Depending on the material, we can take the averaging, but it's definitely times more than XRF itself. Yes.
I see.
And yeah, I'm sorry. And with mass spectrometry, we also here have the, it's effective method for sure, but it also really good with the light matrix, and also requires sample preparation. So if we are talking about the, time and the place where analysis happens, it surely XRF fluorescence has its own advantages, because the analysis could be taken on the site, at the place, and while we are talking about those two methods, you need to bring your samples to laboratory, prepare those samples, then prepare your analysis. So basically the time is a key here.
So basically, if we compare XRF and OES, for example, in terms of convenience and accuracy, what can you tell us about maybe equipment of OES?
Well, let's say this way. It all depends on the task of the customer or of the user, right? If you need to get like a really, really accurate data for light matrix, like if you need the carbon with the data of like 0.001 and this, you can for sure use the optical emission spectrometry, as this method will give you the accurate data. But if you need to have the full picture with the errors of kind of like 0.05 from 0.05 to 0.3, if it's acceptable, there is no need to make the optical emission spectrometry. It takes time, it takes money for sample preparation, and it also takes time for analysis. And, in any way, you will get the same data for all heavy metals, which is the most of the, if we look into the elemental table. So if you need just this analysis, you can go with XRF, and it's way easier and faster.
So basically, choosing the method depends on the elements and the accuracy you want to achieve.
Absolutely, absolutely.
Okay. And what about mass spectrometry? When is it preferable?
Well, with mass spectrometry, we have kind of the same situation as with optical emission, because definitely if you need to have the good results, I mean the very accurate data for light matrix, then you use optical emission spectrometry, and same as the mass spectrometry. Both of these methods are really good for light matrix, light elements. But same, as we said, it has the same issues. The sample has to be prepared. The time is running for analysis is times more than we actually practice. And basically, if the customer have to, mostly interested in light matrix, he can choose between those two methods. But if he's, again, if the accuracy of the data can be more than just 0.000, like, 5 zeros after a dot, he can use XRF fluorescence, because he will achieve the same results. So basically, those two methods are really good if you need to have the good picture, good full picture with the great accuracy about the light matrix elements. Otherwise, you can use XRF with the same advantages as those two methods, but even more with the time, with the non-destruction, and with like almost no methods, almost no fields required sample preparation for us. Just a few, let's say, when we're working with the powder or we're working with a liquid. Otherwise, we don't have any kind of a sample preparation.
And also, I know that mass spectrometry is preferable when you need to analyze some biological or organic compounds?
Yes, it's biological, organic compounds. So it's basically it's good for like organic chemistry or something like this. Absolutely. Then you use the mass spectrometry, and here in this kind of field, like in biological analysis, this is the best method here we have. But for other methods, you know, it has the same advantages or even less than XRF for it. But yeah.
Okay, and what about the cost? Which equipment is more expensive, and where is the analysis cheaper?
Well, if we are, let's talk, you know, separately about the equipment and separately about the analysis. Here we have the like optical emission devices and mass spectrometry devices for mass spectrometry. They cost well way more probably than you know, our spectrometers, especially handheld, because this is the complex method. Both of these methods are really way complex than ours. They require more power. They require more, like some of them more optics. Some of them, you know, as we are talking about the mass, they have their own settings for biological analysis. So also all this goes in spare parts. Also it goes in a technology, in the analytical algorithm that has to work with all the system. And for sure, those devices, they cost way more, like, you know, times more. And they cost their money, for sure. If we are talking about the XRF, our method is, you know, it's like, well, say, in comparison with those, it's general, because it can cover a lot of application. It can also provide you with the accuracy, but here we have the, you know, some kind of a room with the price, because this is the portable technology. Optical emission or mass spectrometry, they usually goes as the desktop, and it for surely costs more. We have the, you know, choice where you can choose the benchtop if you need to work in laboratory, or you know, portable if you work on the field, or handheld. So basically our prices is better, and you know, and we have the reason, and optical emission and mass spectrometry also have their own reason for the prices. And then we move into analysis, and again, for us, let's say that the price for analysis for XRF can cost in some ways for sample preparation, it's not that complex. Some ways you need to use the cuvettes, sometimes you need to use the films, but it's mostly for maintenance. For cost, it doesn't depend or vary on cost that much. We don't have to deal with sample preparations. We don't have to destruct the material and get the new one, you know, so we are just leaving the material as it is. So speaking about the cost for each analysis, XRF is way cheaper in this kind, like XRF fluorescence.
Yeah, I understand that XRF is more budget friendly for most companies and applications.
Absolutely.
So XRF sounds like an efficient choice for many businesses. And Dennis, the next question is which industries use these methods the most?
Well, I can tell you like a lot of different industries. Well, if we are talking about the XRF method, well, main application that is like widely known and that benefits the XRF the most is the application for metals and alloys analysis, because you can use XRF on any stage of production, and like it's really easy and fast. For metals and alloys, it's extremely fast. So from metals and alloys to rare earth elements, where the non-destructive method is really akin, because you don't need to destruct those very expensive materials. And a lot of other methods, but unfortunately, due to the capabilities of our method, we cannot analyze the organic elements. Well, and here comes the mass spectrometry, because mass spectrometry can analyze organic elements, biological elements. Well, it mostly concentrates on it. So It has wider capabilities for light metrics, and this is where it's useful. For a lot of production, a lot of like some pharmaceutical companies also, like as the biggest players on the market, the well-known players definitely use this method for production of their supplies. And also we, for optical emission is the same as some industries that need, that has to work with the really, let's say, not the spoiled materials, I would say, but really the materials where it's like the accuracy is so much matter, where the concentration of elements in any metals or in any kind of a piece is very, very matters. Like, for example, if they talking about the aerospace and like for aircraft or for airplanes, for shuttles, the accuracy of some methods are very important because, the safety first, and if something would be done wrong, it could cause lives of, the expedition of the group. So here's the concentration of elements is very important, especially if we're talking about the accuracy below zero, like 0.00. In such kind, they use the optical emission spectrometry. So mostly, if we are talking about three of these methods, they are good for a lot of industries, and they are compatible with all the industries. However, the question is, do they really need it? Do they really need to overpay for it? Or the companies want to underpay for something because they think that they can save on this one, and it has the room to buy more expensive equipment. So for a lot of companies, those three methods are really good. A lot of industries, but all depends on the cost effectiveness and of the capabilities of each method. So,
So basically, the choosing of the method depends on the material, elements, cost you have to spend on the analytical equipment, and the accuracy maybe.
Absolutely. So we propose the formula. When we talking with the customers, for sure, it's like natural that everybody comes firstly to the price, and the price, if the price is bite or is itchy, people just kind of, pass this idea or just put it on hold. We suggest to work with the methods, with the formula, when, first of all, you should ask yourself a question, what you need this product for, and how accurate should it be. Do you have the analytical task and you need to solve it? So just calculate how you can solve it. Will you be able to solve it with the XRF method, or maybe it's only optical emission can handle it, or maybe only mass spectrometry? So something that you need to understand in which way to move. Firstly, your analytical task. Then the accuracy that you need for it, and only then it should come to the cost. Because if you will concentrate yourself on a cost and try to save this price, maybe your analytical task will not be covered like you wanted at all, and you will lose your money or something on this stage. So basically you need to have the formula of asking yourself what kind of equipment, how accurate it is, and only then come with the price. The most effective method. So
Yeah, I see. I think we have covered all the questions we had to discuss today. Thanks, Dennis. That was really pleasure and very informative.
Pleasure for me also. Thank you, Sergey.
So we hope this video was very helpful for you, and you better understand the differences and the benefits of all these methods. And if you have any questions, you can write down them in the comments, and we will try to answer them.
Yes, and we wish you luck with choosing your equipment and choosing your method. And anyways, our support is always happy to help you. For any questions, you can contact Elvatech. And yeah, thank you, Sergey, for managing all this. And I think we would, sometimes set more such kind of a meeting to answer your questions. Really good idea.
Yeah, definitely. So see you next time on the Elvatech YouTube channel.
Right. Bye.